The world of automation is undergoing a paradigm shift. This changes everything. Welcome to Universal Automation. The world of plug-and-produce software components, making complex things simple and reliable. Think of it as the dawn of an industrial automation app store. The IEC 61499 standard is the key to portability and interoperability. UniversalAutomation.org is the community managing an industrial-grade reference implementation of 61499. Because no one vendor or company or person can bring about transformation on their own. Universal Automation allows us to use software and hardware in a whole new way to create portable applications and innovative architectures. For the first time, IT and OT engineers can easily work together, combining real-time with right-time to create cost-effective and innovative ways to address complex use cases, like predictive maintenance, production optimization, and virtual commissioning. But how does Universal Automation really impact you? Vendors can use the Universal Automation reference implementation to bring IEC 61499 offers to market fast. That means new software revenues, new business models, and new customers. Universal Automation frees industrial enterprises to integrate best-of-breed components and proven in-use software. You can realize step-change advancements in efficiency, flexibility, and modularity with agile operational models. It's time for us to release the full potential of the fourth industrial revolution. Be a part of the community delivering the solution. Join universalautomation.org.
Hello, and welcome to this new session of UAO Goes Live. My name is Greg Bucco, and I'm the Chief Marketing Officer of universalautomation.org. If you are manufacturing goods, you might be facing this challenge of how to ensure the stability of your manufacturing costs when energy prices are being very volatile and sometimes even when they change during the day. How to tackle that while at the same time manufacturing is becoming more and more dynamic with frequent reconfigurations and many operating states. What is the role of IEC 61499 into that? This is what we are going to discover today with DEUS and her tech lead, Polina Ovsiannikova. Polina has been driving the technical approach behind DEUS, focusing on how process-aware and agent-based control can optimize energy use without disrupting existing automation logic or architecture. While she is coming to the stage, do not hesitate to ask your questions online using the chat, either on LinkedIn by commenting this event or YouTube, and then we can ask the question directly to Polina. So Polina, welcome. Welcome to the stage.
Thank you, Greg.
Could you introduce yourself quickly?
Yeah, sure. So as you've heard, I'm Polina. I'm a postdoctoral researcher at Aalto University. Did first my block of research on formal methods, and now it helps me a lot in building the reliable and safe layer for distributed energy utilization system.
That's good. That's good to know. And today your topic will be about DEUS, as I presented a bit. Can you tell us a bit about DEUS before we jump into your presentation?
Okay, so we actually first were inspired by greenhouses because they were failing in their business models all the time, and much of that came from high energy costs. So we started thinking, like, how can we reduce energy costs and at the same time keep the process going, meaning keeping the plants alive. We did some research there, and it was quite successful, like our models worked. But then we thought, why are we restricting ourselves with the plants, like with living plants, when we can transfer our knowledge to the production plants? And it works surprisingly well too, and that's how DEUS came to life. And I will tell more about it in my presentation.
Okay, so then let's jump onto your presentation of DEUS. Great. Okay. And the floor is yours, Polina. Go ahead.
Okay, so as Greg and I already told, we're building DEUS. It's a modular energy management system that cuts factory costs by up to 18%. It brings AI-driven automation directly into PLCs, fully open, vendor agnostic, and ready for the next generation of distributed automation. So nowadays, we are moving towards modular swarm-like production systems and manufacturing as a service. And there is one thing few people talk about: how to feed these flexible factories with energy. In a world where energy supply is unstable and sometimes underproduction happens, and the most important, that grids adapt slowly. So today, the problem is that most plants can plan their energy consumption only roughly. And this is enough to bid on FCR markets and earn from their energy consumption or not consumption, which is already good, and they can adjust hourly. But usually this works only if the process is predictable. But what if we are moving towards demand-driven production instead of planning like half a year ahead the production schedule? What if there every product and every batch has different production recipe, and thus every actuator behaves differently all the time according to the production needs? So that we need something smarter, and we need to switch to a way to tune energy consumption directly at the machine level, and most importantly in real time. So the problem is that current energy systems operate too high above the process. They optimize in the level of meters, dashboards, but they ignore all the opportunities hidden inside the automation layer itself. So the layer that controls the work of each valve, conveyor belt, drive, pump, basically each of your device, you name it. So DEUS changes that. It goes down to that control level and makes the process itself part of the energy plan. So unfortunately, in Europe, manufacturing still wastes a significant share of its energy, and downtime costs losses can reach tens of billions. And much of that comes from a rigid automation that can't react fast enough when conditions change. And that's why real time matters, because conditions will always change, disturbances happen, and losses build up every minute your system can't adapt. So let's make it more concrete. Actually, like the systems that require such kind of modular energy optimization are actually all around us. So they can be physically reconfigurable. You can think of modular production lines and AGVs making routes in between them different all the time, and maybe even this like production places can change their placement, their physical placement. But also systems which are less obviously reconfigurable require such control. So take, for example, water treatment units, where you need to direct, like open different valves all the time. You can think of baggage handling units is a very good example of that, because the conveyors, they stay in place. So like the energy consuming devices, they always stay in place. But the routes, they adjust dynamically, and this also affects how fast conveyors should increase their speed, decrease their speed. Also, they should adhere to the schedule of the flights and so on. Or even building automation comes here, because we have lots of offices with lots of lights. Sometimes the slides should turn on or off. HVAC should turn on or off. Of course, there is lots of research being done there, and there are already firms which optimize energy in buildings. But I'm just telling that this is the same kind of the system. It's reconfigurable, and in practice, it means that they all can exist in hundreds of operating states, and no static control algorithm can cover them all. And that's where DEUS comes in. It learns the process behavior and uses every actuator's potential to reach the momentary energy targets dynamically without rewriting control logic each time or manually reconfiguring the schedule of the production. So our solution isn't just another big central controller or dashboard, which are very popular nowadays. It's a community of smart agents. Each of them is responsible for its own piece of the process. So every agent understands its area of control, its limits, its boundaries, its energy profile, and how it affects the production. Together, those agents negotiate in real time how to spend the fixed energy budget that they are communicated with from the layer above, which can be your MES, which can be your energy management layer, you name it. That's why like everyone creates those high-level agents which tell your MES exactly how much energy your process should consume, like overall at each time, the whole process. But our innovation lies in the runtime agents. So we automatically generate field-level energy agents that sit right next to your actuators and make decisions locally. So this means that you don't have to have constant cloud connection, and you won't have the communication overload. You just have fast process-aware control. And because we built on IEC 64099, these agents are portable and vendor agnostic. Now here I must say that the fact that we built on 64099 doesn't have to do anything with how you implement your system. We just built on 64099 because for us it's so very convenient to support different kind of systems written with different standards, implemented with different architectures, because the standard just allows us to be kind of portable and vendor agnostic and be really reconfigurable and flexible in how we implement solution right into your place. So let's see what it looks like in practice. Here is a simple food packaging unit. It has all kinds of complications I was telling about before. It has different actuators, it has different routes, there are heaters, coolers, and there is a packaging unit, and also we can assume that somewhere there also humans observe the products and maybe slow them down or get tired also. So all of this running in parallel, and this makes this example an ideal case for DEUS application. Now I'll show you what the user normally never sees, a quick look at what happens behind the scenes when we create DEUS agents for you. So at first, we import the data, whatever we have here, just have this simple import, but it can be also from the databases. We distinguish three types. It's visual, system traces, and whatever unstructured data you have. Based on this, we distinguish your energy asset layout, like what kind of routes you have, and based on this, what kind of production recipes you have on your production place. We also identify the main information about each of the actuators, and we also can edit it and adjust it towards the process. So when we are happy, we can generate runtime agents. So those are the agents that we will be receiving the common energy budget, momentary energy budget, and distributing it across actuators so that they consume total amount of energy which is needed, but keeping in mind the production process and adhering to production goals. And we create those agents only for the actuators for which it makes sense to generate them. When these agents are ready, they are also editable. So here we work on how to best configure your system. We can deploy those agents to runtime, to a PLC, to an IPC, to several PLCs, whatever we decided with each particular case. So then we formulate the overall context for our system, so based on which we formulate the energy budget for the whole process. So your system connects to grid, it might have some solar panels, you might have wind turbines installed, and so on. When we have this overall context, we can formulate the optimization goals. So by default, our first and foremost optimization goal is energy cost. So we want to minimize it. But if you want to give more importance to some other tasks, for example, the reducing carbon footprint at some point, like I don't know, 1 month is energy cost that you are caring about, 1 month is carbon footprint, whatever. We can provide this capability too. So this is our high-level agents. This is IT layer. If the previous layer was OT, operation technology layer, so this is IT, information technologies layer. And this can exist alongside your energy management system and communicate with it, or also communicate with your MES. The thing is that this layer is above our field agents, and this layer provides input to our field runtime agents. So this is what user sees. We are not a dashboard, but we had to create dashboard because people need to see what they want to see, and usually people want to see understandable charts. So this we also have. And this what user experiences, and I think this is the best part of this all. So this is the conveyor system, which you can have almost like in any production place. And now our conveyors run in 100% of their speed, with the sole goal to deliver the work pieces as fast as they can. Each of these conveyors has a DEUS agent communicating to it. And look what happens when we provide the energy consumption target from above. So almost immediately, the overall consumption of the whole system, all the conveyors, reaches the set target. And it adjusts dynamically in real time. And it doesn't only slow down the conveyors or speeds them up. It does it in a way that it affects the process itself the least. So the conveyors with the workpieces, they run faster than conveyors without workpieces. And this is monitored and changed in real time. So DEUS connects where it's needed. In traditional pyramid architecture, it connects to your MES or your energy management layer, or to our IT agent, depends on the case. Then it takes the planned set points for the whole process and refines them into the real-time targets for the devices for the control level, and basically for the devices. And in modern service-based architectures, it runs as a service alongside your existing automation. So also getting inputs similar to the ones that we get in Pyramid, but just from other services. Well, either way, you get the real-time process-aware energy control without changing your system design. So why try those? First, the obvious part, it reduces your energy cost. In our pilot systems, we've experienced 9 to 18% lower energy use, which depended on the process type, on the actuators type, and on overall process flexibility. Second, it makes production greener, because usually, not always, but often when energy is cheaper, it's because it comes from renewables. So DEUS automatically shifts consumption towards those moments, using cleaner power without interrupting production. Third, it keeps your factory running smoothly, because during downtime or disturbances, since we have this not a rigid automation structure, but our agents communicate to each other, like running your devices, seeing the devices not running, and observing the process. The system reallocates energy dynamically, and that means that your system can recover faster, and fewer penalties for missing energy contracts will be taken from you. And what's less obvious is that now, as I've been telling all this time, we are coming from this very high level of energy optimization, where we see how our whole factory, or like big chunks of the processes, consume energy. We go down to the really process aware control, where it's in this level that you can start thinking about the demand responsive production. And one spare pros which we actually found out during our experiments is that our real-time control reduces energy oscillations. So it means that it will, as a side effect, protect motors and drives and other equipment from unnecessary wear. So now we are opening those for pilot partners. We are really eager to hear how you want to reduce energy cost. What is your process? If you have such requirements as you want to start this demand-driven production, or you're preparing your factory to serve in the manufacturing as a service framework, or you have different dynamic recipe operations and you want to introduce more recipes, but it's already too crowded, and you wish to learn how we can organize this pile of recipes into a smooth functioning factory and reduce your energy costs at the same time. We are all here for you. We want to face reality, and we want to reality face us. So this is me. I'm Polina. You can follow me on LinkedIn. I'm telling some behind the scenes from how we are advancing and what kind of things we face on our path. And you can also drop us an email if you got interested in what I'm talking about by just scanning this QR. Thank you.
Thank you, Polina. Let's keep that on the image to keep the time to the viewers to really get your contact details and be able to contact you. But and I would like to start with one question, listening to you, which is about you said that you have done pilots so far. Were you able to estimate what were the energy savings that you could get on those pilots so far?
Yeah, it was from 9 to 18%. So
okay.
Why this interval? Because we were using different actuators mix. So I don't know if I'm allowed to tell with whom we were doing this, but I can say that it was greenhouse, because like greenhouse, we started with greenhouses, so we started experiment with that. And for example, if we connect lights only, then we can have a really huge impact. But if we connect also HVAC unit, which is not as flexible, which is like not as controllable, then it's already a bit less. So
Okay.
so that's why from 9 to 18.
And another part which came to my mind, because you show a lot about the manufacturing side, so let's say a discrete automation, but could we also adapt let's say the Asian to a more process automation or process oriented automation? Did you already kind of have experience or know already if you can use that for this kind of applications?
Yes, of course, we can also introduce it to process automation. We did it in again greenhouse case. We were developing lots of models of greenhouses. Now we are also starting working with one water treatment unit. We're just starting, so I can't tell a lot about those results, but yes, it's applicable.
So,
and about the
okay.
model of greenhouse, because there were like, this kind of equations where environment changes all the time, where like humidity changes, like different sets of actuators influencing the environmental parameters. So yeah, we worked with that, and yes, DEUS helps there.
So basically an ability to use this technology or this system, let's say, in all kind of industries. Is that correct?
Yes, we are targeting all kinds of industries, because what we're interested in is actuators that are consuming energy, like preferably like heavy energy consumers, because that's where you can give the most impact. And then we just see how they influence the environment, what they are. We create models and yes, apply our optimization techniques.
So then it leads to the next question, which is, I see that this is, for me at first, it looks great for let's say greenfield application, and actually that's one of the feedback that we also have from Universal Automation.org side, that the technology is only or people might think that the technology is only for greenfield application, even though we are showing as well that we have in fact a lot of use cases in brownfield. And one of the use cases that we had a couple of months back with the company Consumer Maritime exactly shows that part. But I would like to extend the question as well to DEUS. Is DEUS like only for greenfield applications, or can it be considered as well for brownfield applications, so for applications which are already existing and running?
Yes, of course. It's very nice that when the process is just in plan, where like the factory is undergoing major innovation and so on, it's of course much easier to install something new to such factories, and yes, that's when we can install those there. But we also can support the existing processes. And actually, our pilots now are exactly on this side, that we take already existing process, like of the stakeholders, and connect those to their processes, and see how we can influence their energy consumption.
And how would integration look like when we have an already existing system, for example?
So at first, we of course analyze the whole process. We talk to stakeholder. We see what kind of data we have there, what kind of layout, what are the main targets, what they already have. Maybe, for example, they already connected to some firms that provide this FCR market trading for them, and so on. So we first analyze this. Then we design a simulation model for them to show that, like, okay, here's your process without us, here's your process with us. And then as a final stage, how we implement it physically, it's that we are running generally everything on IPC. And then IPC communicates via OPC way or Modbus or like any open-ended communication protocol with the on-field PLCs. However, we also have a provision in which, if the company wants, we can deploy like certain parts of our algorithms to their PLCs. Like it's all case by case also.
So very, very flexible, and depending on the cases that you are basically facing.
Yeah, we are starting now, and we are curious about everything, and we are really willing to make life of people who contact us better and reduce their costs.
So I just may pause here to tell the community to feel free to ask your question. The chat is there. You can go on LinkedIn, make a comment. You can go comment directly in the event, and we will see your question, and I will give it to Polina. Or you can go on YouTube and ask your question again. Feel free for that. And while the viewers are, let's say, reflecting on what they will ask you, I will go on with my question, which is, which kind of data do you need in order to, let's say, integrate properly the technology that you are promoting?
Well, the more we have, the better. It's always like this, but like, of course, the ideal case is, for example, the factory or the process already bought the devices that have those energy management units within them, and they're all so smart. They communicate with the cloud. They have the whole database of all kinds of data there is. So this is the best case. Like, we can infer really nice from this kind of databases of data about the processes. But this is a very rare case. So what we do is that we deal with what we have, and usually it is some kind of schedules here and there, some kind of like, which they can share also, because even under NDA some might hesitate, which is also fine. Like, before they get first results, then they hesitate less. Like schedules, this high level energy measurement data, because usually, like, for the whole process, they usually have the energy measurement data. If the process is very old, like, for example, it was implemented in 70s, where there was very few sensors, and people just have this kind of fixed energy contracts that they just pay, and that's it. Then we analyze this process ourselves. We go into the whatever documentation they have about that, and we make the picture of the process, and then we make suggestions on how they can improve it. Like, we make models for them of the parts of their process at first, and like, little by little, we assemble the whole picture.
So basically, what is the minimum viable pilot, how it looks like in terms of number of actuators or lines? What could be, let's say, for maybe a proof of concept, or for pilot, what could be the minimum size that you would need in order to, let's say, start using DEUS?
I think it depends a lot on how the customer would like to start. Of course, we would want some energy consuming device, at least one. I don't know, one HVAC unit, one heater, or one cooler, something that consumes lots of energy. So we can start even with one. If the customer wants to, like, not the customer, but like the person with whom we work at first, because we are a Business Finland project, and we are not taking customers now. Now our pilots all go for free. So yeah, that's an important note. But yeah, so whatever they feel comfortable to start with. If they have series of conveyors, then we can start with just series of conveyors. The point is that when they will see the first results, then we can already start talking about extending it. Maybe like before we worked only with this, I don't know, heating chain, I don't know, heated packaging units, like heated packaging line. Now they saw that it's okay, they can give us the cool packaging line. Or again, if we talk about greenhouses, we can start with just like one row of plants and one lamp above them. So anything goes, like as long as we can demonstrate the results.
Okay, sounds great. Sounds all right. And I think those would be maybe the closing words, unless you have something to say to the audience before we close the session.
Email us. Let's talk.
Yeah, I think that's the
Thank you
that's
for
the right call to action. So maybe you can see your details on the screen, so people can directly contact you. So Polina Ovsiannikova at alto.fi. And I would like to thank you, Polina. Thank you, everyone, for joining this session. So today we have explored how intelligent agents at the control level can contribute to energy efficiency in real time, and how 6.99 supports portability and vendor independence in this approach. This approach can fit to any environment, brownfield, greenfield application. So that's a really great approach. And if you're interested in learning more about it and exploring a pilot, so for sure, please contact Paulina here, and she will get you up to speed. So again, on behalf of universeautomation.org, thank you to all for being part of this live, and for watching us and listening to us. And I wish you a great day, and looking forward to the next session of UAO Goes Live. See you all, and see you. Bye.
Thank you, Greg.
Thank you. Bye.
Thank you, Greg.